again for the last time, hopefully. So, yesterday you had a visit to the aero department, and also you saw some of the work going on and possible areas of work in ground vehicles as well as unmanned vehicles plus air vehicles. Okay. So, that is a department. Okay. So, most of this which we are covering in one day are actually departments. So, it's very nice to say you look at this aircraft flying and you look at this helicopter, okay, but then you have to remember that it's a department actually. So, everything looks very nice, but then it's not very easy the way it looks. But there are possibilities of trying to do something very small, okay, in the area of robotics, autonomous systems, okay, with whatever you have seen. So, today we are at the end, the last day today. A lot of people are in a hurry to go back. Okay. So, we'll have 1 hour class probably. So, the last topic is Industry 4.0. Okay. And then we have an exam. Okay. And then we'll have the much awaited certificate distribution, and then that is the end. So, let's have a brief class today on Industry 4.0. So, this term called Industry 4.0 was somewhere started around 2011, and it is basically originated in Germany. Okay. Now, there are various historical perspectives of why this term, okay, why it came here, and why this term is used, etc., etc. But let's just try to understand the relevance of this in today's industrial scenario. So, Industry 4.0 is a continuation of industrial standards called Industry 1.0, 2.0, 3.0, 4.0. Okay. And very long ago, about 1963, it was observed during this is the time of Industry 3.0, probably around 3.0, that automation is something that is not our enemy. Okay. So, when we talk of robotics and automation, one of the concepts that come out or something that comes to your mind is it will take away jobs, and it will cause unemployment, and it will cause all kinds of problems. Okay. But this was also felt long time ago in the US, 1963, and at that time this was debated a lot, that whether you should go in for automation, you should go in for robotics or not, because of this negative connotations also. And there it was felt that, so a committee was set up, and then the president ultimately came up with the famous lecture that automation is not our enemy, but our enemies are ignorance, indifference, inertia. So, automation can be an ally for our prosperity if we can just look ahead, if we will understand what is to come, and if we can set our course wisely for proper planning of the future. So, this part of proper planning of the future is required. But today where we have come is essentially we see that on one side the cost of automation is coming down, on the other side the cost of labor is going up. And to be competitive in today's world, okay, there does not seem to be any other way but to automate. Okay. So, automation of different kinds which have come in. Okay. Now, so somewhere around 2011 in Germany, this term was coined during the Hanover. This is a trade fair. It happens every year in the world. All industries come there and they have a world trade fair. So, this term Industry 4.0 was first used there, and it basically means that by connecting machines, workpieces and systems, businesses are creating intelligent networks along the entire value chain that can control each other autonomously. Okay. So, we are saying that industry has evolved, okay, and this evolution has come to a stage now where you have machines, you have human beings, you have value chain. Okay. But what we need to do is that we need to connect the machines, workpieces, systems, human beings, and create intelligent networks. Okay. So, this is something. Intelligent network means a lot of people call it network control systems. So, it can be that something is being designed in India but is being manufactured somewhere else and is being sold in some other country. And what is this network? A network can be simple internet, okay, which is there today. That you can design something using CAD and you can download it into some place else where they do rapid prototyping, make the product and give it to somebody else. Okay. So, a lot of people call this intelligent networks, some people call it network control systems also. But something about this Industry 4.0 is that we need to connect using intelligent networks along the entire value chain. So, till now manufacturing was manufacturing, design is design. But what this concept says is that you need to connect the complete value chain. That means right from the person who is buying your product to the person who is making the product, and after sale after sales, then your even even activities that come after sales is done, repair is there, okay, then disposal is there. So if you can connect this full entire value chain by means of networks and connect machines, workpieces and systems, then you can go into the next industry, industrial standard, which is Industry 4.0. So a lot of companies are actually trying to go into or trying to implement 4.0. So what has happened is big car companies like automobile companies, they manufacture cars in one place, parts come from some other place, design can be done somewhere else, but they are not integrated. Okay? So this integration is something which is required in Industry 4.0, and a lot of the companies are actually trying to implement this. Okay? Different terms are used. In, network control system is used, AI is used. AI is essentially used for this integration only. So this is a new term which has come up, and apparently it is likely to stay for the next 10 to 20 years. And a lot of the companies are actually trying to enforce this Industry 4.0. It is still not very clear. It is evolving. Now, is it only industries? Well, the answer is no. The answer is it has got inside everywhere because of this business of intelligent networks. Example is Amazon. Okay? Amazon, if you think about Amazon, even you are connected to Amazon. Okay? All of us are connected. So it is not that it is only manufacturing. So here when they talked about automation, they basically talked about manufacturing and automation. Here it is not manufacturing automation anymore, it is everything. Okay? What about education? Yes, even education. Okay? So education, like the conventional education we used to have where a teacher comes and teaches something and then you have an exam, that is being replaced by online courses today. Okay? So even education has changed. Maybe after 10 years there will not be a teacher, there will probably be a robot, or there will be some virtual character who will be giving classes. It is going to happen. It is already there in many places. But around the other countries in the world, it is of course there. Like in countries like a lot of places in Japan, then in Scandinavian countries, where they do not have primary school teachers, because primary school teachers are paid the least, so nobody wants to become a primary school teacher. Okay? So they are trying to replace by robots and other virtual characters. Okay? So already this is there. So it has got into all aspects of society. It is not that when we say automation, we say robotics, it doesn't include us anymore. It is not like that. Okay? It is everywhere. Now, if you want to survive, then you have to be a part, or you must have some idea about this. And secondly, when we are training students, students should know that what is it that they are expected to do. For example, if you want to start up a company, what are the possible startups which are there now? Okay? You can't make robotics and automation company, that's not possible. Okay? But a lot of other things are possible now. Okay? If, for example, automatic warehousing is possible, making apps for doing purchase, sale is possible. Okay? So this idea of Industry 4.0 is catching on everywhere. The government of India has also set up a task force and all that was there a couple of years back, where they said for Industry 4.0 in India, what are the focus areas, what are the companies which are important. All countries have set up. Germany has set up, US, Japan, Singapore, okay? China. All of them have their now Industry 4.0 task forces who are saying what should be done in which industry. Similarly, we also have for education. Okay? What should be the direction in which education should be going now? Okay? So Industry 4.0 essentially is connecting machines, workpieces, systems, businesses, and humans, and creating intelligent networks along the entire value chain. So something which is very common here is that number one is this business of intelligent network over the internet, which means over the internet, and the entire value chain right from the customer to the production to everything until the end. Even disposal, we say today green disposal and things like that. So it is connected everywhere. Okay. So we started off with automation here, and we are somewhere here now where we are saying not only automation and robotics, but it should be connected over the net, etc., etc. Now, these are some interesting things that are going around. Okay, maybe you can read. So there is a book, actually, AI Superpowers, 2018. It was published. Okay? And the name of the book is AI Superpowers today. One they say is China, and the other is Silicon Valley. Okay? These are the two AI superpowers of today. And these changes are coming. We need to tell the truth and the whole truth. By truth, they mean that jobs are going to go. It is not that jobs are not going to go. Jobs are going to go. There's no point in telling that jobs are not going to go. Jobs are going to go, but new jobs are going to be created, different kind of jobs. Okay? So which means that when we are training students, they also have to be trained in a particular way now, what kind of jobs are available. So we need to find the jobs that AI can't do. So in terms of robotics, we said that there are jobs which AI even today cannot do. Robots cannot do automation reinvent the way education is going on. Otherwise, in the next 10 years, 20 years, most of the conventional education fellows will be out of business. Okay, that's going to happen. Okay, so so this is a book that was published by Professor Lee, MIT 2018, and he of course has a lot of other things to say. And essentially, the countries which have been moving in that direction, one is here, China, and the reason China has overtaken most of the countries in the last 10 to 20 years is essentially because of this only. They have been able to find which are the jobs which are going, which are the jobs that are being created, and how to replace them. So first of all, we need to find jobs that AI cannot do, train people who can do them, and we need to reinvent education. So this is an interesting book. It's available on Amazon. Maybe you can buy it and read it. Okay? Because education is something that we need to reinvent now, and we need to do it quickly. He also says that if we act rationally and quickly, we can bask in what's best rather than wallow in what's worst. So if we act and make changes accordingly in terms of what jobs are available, what jobs are coming up, trying to change our education way, the way we are teaching, then and act rationally and quickly, then we can take the best of what is coming in the future. Okay? Otherwise, we are likely to keep saying that jobs are going to go, there are no jobs, unemployment is going to come up and all that. Okay? So with this background of this, let us look at industrial. This is something we have looked at before, the industrial revolution. That essentially industrial revolution started with mechanical production powered by water and steam. So this is about end of 18th century or before 18th century. Okay. So most of the machines were driven by water and steam. Then we came about beginning of 20th century where machines were being driven by electricity. Okay, so this is what. So essential difference being the driving power. Here it is steam, water. Here it is electricity. Industrial revolution is basically computer based. So this is what we say or basic automation. Okay? So we have automation of robots, then we have automatic machines, computers. So this is the industrial revolution. This is about 1970s. So we are here today, which is industry 4.0. We call it industry 4.0. We can also cyber physical system, etc., etc. Okay. Now the basic difference between this and this is connecting the complete value chain right from end to end, and there is a human in the loop. And most of the Indian new industries, not Indian, I mean anywhere in the world, okay, like retail, like Amazon, Flipkart, Uber, Ola, all of them are here now. They are connecting the full chain with machines, human beings, some kind of virtual reality, and some kind of AI-based. So we are here now, and this is where we talk about Industry 4.0. So this is the industrial revolution in a way, how industries have been going. And this is likely to stay for the next 10 to 20 years at least. Now, these are the phases of the earlier industrial revolution. So this we have seen in terms of basically driving power, which was steam and water. Then here is electricity, here is computers, semiconductors, and the fourth one is basically interconnecting computers, humans, and okay. Now, what are the 4 design principles in Industry 4.0? So what are we trying to say here is that if an industry wants to implement 4.0 or they want to move towards 4.0, what is it that is required? So first of all, there are 4 things that are required. One is interoperability. Machines, devices, sensors, and people to connect and communicate with each other via internet. Okay? So this is the first thing that is required, which was not there till now. The question of connecting machines, devices, sensors via the internet, essentially, or over the internet. So interoperability of machines, which was not there till now. So some kind of code or some kind of interface where machines, humans, and others can be connected and over the net. So this is the first thing that is required. Okay? The second thing that is required is information transparency. Now this, interestingly, one of the big challenges of Industry 4.0 where they are trying to implement is in healthcare. Healthcare is one, agriculture is the other one, education is the third. So healthcare is one where there is a lot of possibility of implementing this 4.0. Interoperability of machines, transparency of information. So information system to create a virtual copy of the physical world by using digital plant models or sensor data or whatever. Okay. So one is interoperability, second is information transparency. So information systems to create a virtual copy of the physical world. So whatever decisions are being taken are at the physical world, are not in the physical world, but in the virtual world. Ola, Uber, Amazon, these are all examples. Okay. Whatever decision is taken in the Ola cab is not in the real world, but is in the virtual world now. Okay. Using data from the physical information transparency to go between worlds, real world, virtual world. So the first is interoperability, the second is information transparency. The third is technical assistance systems to support humans by visualizing information comprehensively for making decisions. So most of the decision till now is not made by a machine, but is made by a human. Okay? So the technical assistance to a human. So if there is a human who is sitting somewhere else, okay, he should be able to see the complete system or the complete model or the complete plant, and he should be helped in taking the decision by visualizing information comprehensively for taking the decision. This can be done by cyber physical system. It can be taken by large number of sensors, okay, into the virtual world. So the second is this technical assistance to a human. Till now, the final decision is a human decision. Third is decentralized decision. Ability of cyber physical systems to make decisions on their own and to perform their tasks as autonomously as possible. Okay? So there is a machine, there is a human, there is a virtual world. So some decisions can be taken here, decentralized decision, and some decisions can be taken in a decentralized way, but most important decisions can still be taken by a human with assistance from here. Okay, so any company which is trying to do, lot of companies, Tata Motors, Mahindra, they are all trying to implement this now into their systems, and this is somewhere where they need to look at interoperability of machines, connecting machines over the net, transparency information, okay, then technical assistance and decentralized decisions. So these are four basic building blocks that are looked at for moving a conventional industry into Industry 4.0. Okay. Now, if you look at very simple companies like Tata Motors, for example, most of the companies do not have information at all. Okay. The same company, if you say how the car is being designed, they'll say the design department is doing it. Okay. That's the way it's working. Okay. So this interoperability of machines cannot happen unless there is information transparency, and this has to be enforced. In the medical field, if you go to the doctor, there is no record of your treatment, what happened in the past. It's not there, right? It's just not there. In countries, it is there, like countries where they have the national health insurance and all. The moment you go, everything is centralized. The person, right from when you are born till now, can see which doctor you went to, what medicines you had. Whereas in India, it's not like that. You go with a prescription, if you have a prescription. If you don't have a prescription, it's too bad. And some doctors won't even ask you your history, what happened, or did you have an operation, what medicines you are allergic to. They'll just look at you and write the medicine. Okay? So if you want to go to the next, we need this information transparency. We need the information. In our country, it is not there. It's just not there. Okay? Not only for industries, for human beings, it is not there. Okay? So this is what we require. Interoperability, transparency, information, and technical assistance, okay, then decentralized decision. Okay. So these are the four building blocks of. So these are a collective term of technologies and concepts of value chain organization. Number one, builds on digital revolution, smaller and powerful sensors. This we have seen in this course also, that sensors have become very, very powerful today. They are very cheap and they are very powerful. Okay. So all kind of information can be taken using sensors. Machine learning. Algorithms have been developed which can learn by themselves. Okay. Then human intelligence augmented. There are algorithms which can help human beings take decisions. Ubiquitous internet. Ubiquitous internet means internet which is prevalent or available everywhere. Again, it is like that. Anywhere you go, at least you have access to net. AI is there, and robotics and automation. So these are some of the building blocks of which was talked about in Germany in 2011. That these are the building blocks on which we are having this concept of Industry 4.0. How it has affected different companies, how companies are trying to move. One is the automobile industry. So what used to be a car used to be basically an IC engine, petrol or diesel, made by mechanical engineering departments, or it used to be taught by mechanical people. Okay. Companies are headed by mechanical fellows sitting in the workshops or doing manufacturing. But today, if you see, a car is made by Google and is made by Apple. Okay. So the whole concept of having an automobile industry has changed. Okay. So if the automobile companies want to survive, okay, then they need to move in this direction. In fact, most of the companies today in India also, Tata Motors, Mahindra, they are trying to move in this direction. Autonomous cars, electric cars, okay, okay, intelligent cars, all kinds of things where we are trying to, where the automobile industry is trying to move from the conventional automobile to the other one. So we say that very often in a course like this, when we teach sensors, actuators, controllers, then I'm told that the students say that I'm a mechanical engineer, I don't know any of this. That's the most common comment you get, even from students. I'm a mechanical engineer, I'm not expected to know this. Okay? It's not like that anymore. Okay? It is not like that anymore. Okay? So the other complaint also we get even from our students is that when they join companies, they do not know what is happening on the ground. If you go to a car company, they would expect that you know sensors. They would know, because a car today has a lot of sensors. A car is more electronic than it is mechanical today. The electronic stability is there, engine injection is there, okay, parking is there, then ABS is there, which is more. So if a mechanical engineer says he doesn't know sensors, doesn't know controllers, it's of no point. Okay. So when we are teaching, we have to keep that in mind now. Okay, that the direction in which things are going is going towards self-driving cars, then going towards all kinds of other areas, which is not strictly mechanical anymore. And it's not right to say mechanical, electrical, computer science anymore. They are all integrated now. We should know everything. When we are teaching, there should be a course on sensors, actuators. There should be a course in controllers. Okay? So everybody should know that. Similarly, somebody from IT, the gentleman sitting there, has been complaining to me all the time that I never studied all this. You are talking of all design and linkage and sensors, actuators. I'm IT. I did not study all of this. You have no excuse. You have no excuse, because in IT also today, they are going in the same direction. If you look at TCS, if you look at Infosys, okay, they are also going in the direction of, because IT is more or less saturated now. So they are also looking at interfacing hardware with software now. What is next? What is available? In terms of business, what is available now? So what is available now is integrating hardware with software now. Okay, IT is finished now. So when we are teaching also, we have to keep these very simple things in mind. So in the automobile industry, this is, so these are Google cars. Apple also has their car. A lot of the companies are starting off with self-driven cars. Ford has. Okay. So we have industrial revolution, power revolution, digital revolution, then information revolution. Okay. So this is something that we need to, so this business is that we need to accept this first. If I keep saying that I'm a mechanical engineer, I will not do anything more. Okay. I need to accept it first. Teachers have to accept that it is like that first. And then tell the students that, okay, this is the way, and we need to design our courses accordingly. So car industry is one big industry where this change is coming. So this is the other Earth converted into a huge brain. This is something Tesla said in 1926, that the Earth is something which is connected now. Okay, it is not that we are separate, that we are separate in terms of countries, in terms of industries. It's not like that anymore. Everything is connected into one large brain by the internet, and everything is connected to everything else. So for example, smart metering is an example in electrical consumption, where you can sit in your home and the electricity bill will come. Okay, so the person doesn't need to come and check meter. Smart building. So one of the biggest business opportunities in construction is now in smart building. All buildings have to be green, they have to be smart, whatever that means. Okay? And very simple things, like putting sensors everywhere, people are making tons of money. Okay? Simple things like opening a door, closing a door, if somebody is inside, okay, putting on light, putting off light. In cars, they have started next generation cars. I was reading in the newspaper that the new, I think the Maruti car, that Brezza, okay? It's a next generation car. What is the next generation car? It has automatic rain sensing wipers. When you think about it, it's funny. So they have put one sensor which is sensing rain, and then it can automatically start the wiper. Okay. Or switch on the light when the outside light is low. Now if you think about it, it's a joke. I mean, a 200 rupee sensor can do that. But that is the way it is. So if you're looking at new business, we're talking in terms of automobile industry, we're talking in terms of building automation, we're talking of, and it's very, very cheap, and anybody can do it actually. Okay? So this is where most of the new businesses are. This is where people are looking at for jobs. Power grid, smart grid is something which is there. Then room automation, we are talking about building automation, room automation. Okay. So this mobility, health, education, all of them are because this world has been connected by a grid now, by the internet. And anything can go anywhere. Okay. Room automation is another one where very simple devices are being made and people are selling a lot of this. So the breakthroughs that have taken place essentially are communication technology is one, embedded systems is the other one, semantic technologies is the other one. So some of the breakthroughs that everybody and everything is networked, and this is the networking part, is because communication technologies in terms of bandwidth and computing power has gone up drastically. Okay. It is also being said that if you notice very carefully that PCs are more or less finished now. Nobody buys a PC anymore except in offices. They buy laptops. Because it is cheap, you can take it anywhere, it is as powerful. Next generation, they are saying it is going to become mobile phones. Mobile phone has become so powerful that you don't need a laptop anymore. From a tablet or a mobile phone, you can play a PPT or you can do your program, keep it in the cloud. You don't need a laptop anymore. Okay? So that is the direction in which it is going, essentially because of this communication technologies, bandwidth has increased, computational power has increased. Number two is embedded systems, miniaturization of controllers and becoming more and more powerful. So the power of the microcontroller, the Arduino microcontroller we are using is 3 megahertz. Okay. 20 years ago, your Pentium 1, 2, 3, those Pentium machines were actually 3, 4 megahertz. Okay. Today, a mobile phone or a microcontroller costing 500 rupees is more powerful than that. So this is the direction it is going. In terms of robotics, it is car infrastructure, automatic transport, which is there in many countries, it has already come in. Okay, trucks which are moving in particular lanes, automatic taxis, then multi-agent systems, team robotics, factory, smart grid. So these all have happened essentially because of communication technology, embedded systems, and semantic technology. This is information integration. Okay. So all the information that is coming is being integrated, is being learned, and some decision can be taken with that. This is an example of the robot platoon of truck. This was called the Kinovai project, okay, where they see that the trucks on highways, they go on particular lanes only. So this was done again in Germany, where they have made special lanes only for trucks, and this truck is driverless. Okay, so these trucks are driverless and they go in particular in lanes only, and these trucks all go in one platoon, and it's called platooning of trucks. So there is a central server which is controlling multiple trucks to go from one point to another point, delivering goods or whatever. Okay. So this is an example of the next generation of connectivity or distributed control, where from a central position they are controlling a large number of vehicles autonomously. Okay. There is nothing which has been not touched. Okay. Shoes, yes. If you buy shoes today, you can buy a shoe for 400 rupees, and you can buy a shoe for 40,000 rupees also. Shoe which will keep a record of your footstep. Okay. It will keep a record of how much you have walked every day. Okay. So the Nike shoes already have that. They have controllers and processors built inside. Okay. It can communicate with your phone also. Okay. So this business of decentralized control in terms of putting sensors, actuators has gone right only from not only in industrial automation, but for very simple things like shoes, clothes. You get jackets by which you can recharge your mobile phone today. So it can absorb the light, and with that it can charge your phone. So there are also jackets which will sense your movement. As you're moving, what is happening? It is generating electricity and charging your phone. Similarly, shoes which can charge your phone. Okay. So this business of sensors, actuators, controllers have gone in everywhere. It's not that it's only in industry and cars. It has gone in for clothing. It has gone in for shoes. It has gone in everywhere. Social robotics. This is man-machine interfaces, essentially for teaching. So this is the other area where a lot of work is being done, essentially in machine-machine cooperation, machine-human cooperation. In trying to understand when we say human intelligence, human behavior, what does it mean? So if a human is doing something, or the robot is teaching a kid to play a game, what is it that actually is being learned? Okay, why? this will be used for the next generation teaching now. Okay. So first we need to understand ourselves, then we can talk about teaching others. Now in coming to interdisciplinary science and education. Okay. So interdisciplinary science and education, number one is natural language communication. Okay. How do machines, how do humans communicate, and based on that, how can how can we augment human-machine interaction? Okay. So understanding natural language, this is still a barrier, but machines are already coming in. Alexa is there. Okay. Your normal laptop also has assistants. Google Assistant is there. So understanding natural language and natural communication, not only verbal but other physical communication. So for better human-machine interaction, smart logistics, multiple cars doing a task, so swarm robotics, cloud logistics. Then from this side, automated driving, okay, lightweight robots, autonomous flying, autonomous systems. You saw yesterday that there is a lot of demand for autonomous systems coming in now, not only for cars, for aerial vehicles, for drones, for everything. Then social robotics. So a lot of the machines are living in society today. So social robotics is another area where there is a lot of requirements. So all these are interconnected. So this is why the term interdisciplinary science has been used. Okay. So all of these are interconnected between electrical, mechanical, computer science, aerospace. Everything is connected now. Now the impact of this Industry 4.0 has been studied also. Now basically it generates new business, and this business at a national and global, then it affects society. From a society it affects an individual, and then the economy. So this is getting interconnected now. Okay. So we are interconnected between a local person at the societal level, at an individual level, and the economy business at a global and national level now. So in a way we are all connected. So it's very interesting to find that that I had ordered a keyboard on HP just to add it to the laptop, and then it came from the US. Okay. So I bought a keyboard for 1,500 rupees or 2,000 rupees, and that actually came from the US, but then it was actually made in Bangalore. So actually from Bangalore it went to the US, from the US it came back to me. Okay. So I mean here, so we are interconnected in a way that individuals are connected to the economy, to business, national, global. The national, global itself is gone now. Okay. And then we are all interconnected in terms of this Industry 4.0. And this is the direction in which it is going. Okay. From the business perspective, this is a very interesting, something very, very interesting. So interesting in terms of these new products which were developed or created. How long did they take to reach 10 million customers? Okay. So if you look at the telephone, it took 75 years. So if you look at the web, it took 7 years. If you look at Facebook, it took 4 years. Instagram is 2 years, and Pokemon Go is 1 month. Okay. So if you look at that scale, okay, at which a product is being used by a very large number of 100 million customers, then the time is less than a month now. Okay. Something which is being generated in the US, for example, because of this cycle, okay, is getting to very large usage almost immediately. So telephone, web, Facebook, Instagram, and then Pokemon Go is 1 month. So new products which are coming here is sometimes less than a month, okay, to get into that kind of users. So that is what some of the students, when they talk about making a startup. So your startup will either start up or your startup will not start up. Okay. So if you are lucky, then you can get into that scale in less than a month. So a lot of the people who make startups, what they do is they try to make a startup and they try to sell it to another startup. And that is what they do. I don't understand what they do in startups, but there is a lot of students doing startups and they get very good salaries, but I don't know what they do. And it appears to be that you have to make a lot of good publicity and good PR, so some big company will buy you, that there's a lot of market value. Okay. So this idea of starting something new can go to a very large number of customers in a very, very short time. How does this affect you? For example, from 2006, this many products. It's not that products are not there. Okay, so when we look at this, when we talked about this one, okay, that this is something which came about 75 years, 7 years, 4 years, 2 years. And how does it affect you? So these are the products which did not exist in 2006. for example, iPhone, iPad, Kindle, 4G, Uber, Ola, Airbnb, Android. None of this existed there, but they are existing now. So it means that there are products which are being created, which are going to very large users in very short time. Okay. So it is not that it is just being talked about, or this is just a presentation. This is actually happening in the world, right? And this is what the startups and new idea companies are trying to bridge on. Examples of product evolution: connected and smart products, Philips lighting. Okay. This is already there. Okay. Lights which can sense, which can be put on and put off using the smartphone. Okay. Then it can sense if it is getting dark and switch on by themselves. So a light bulb from Philips, which is already there in the market. It's there in the Indian market also. Then Medontric is there, digital blood glucose meter. This is clothes available. This is the clothes which can actually keep track of distance covered, calories burned, movement, heart rate, all kinds of things. Then this tennis racket. So this tennis racket can actually has sensors and connectivity in the handle, so that it can analyze your strokes and even suggest how you can play better. Okay. So this is the tennis racket again, which is there. So these are already there, and this shows the examples of product evolution, connected and smart products. So each of this has something in common. What is common? Sensors and some controllers. Okay. So some sensor, some very simple sensors. You'll be surprised that there are very, very simple sensors. Okay. And controller is again very, very simple today. Cyber physical systems again. So we talked about this communication between this three: computation, control, and communication in a cyber physical system. And this is today's factory. Okay. So we have a car company which is producing cars on a transfer line, and at different workstations something is being done, and finally the car comes out. So the future of the car company is supposed to be like this, in parallel, that the car is not being assembled in one place, but different things are being made in different places, and it can work in parallel also. Potential implications: robot assisted production, predictive maintenance, additive manufacturing for complex parts, machine as a service, big data, production line simulation, smart supply network. So each of these are subjects in themselves today, right? So robot assisted production, predictive maintenance, additive manufacturing, which is already there. So we have to manufacture something. You have to take it to the fabrication shop. Today, right from the CAD model, we can manufacture using rapid prototyping. And the focus in robotics research today is in trying to embed the controller and sensor in the structure itself. Okay, so in terms of research in manufacturing area, design area, is can you make a device in which, for example, the wires, the controllers can be embedded in the structure itself. And a lot of new robots are coming where there is no wire or there is no controller, it's a part of the system. And it can be done by this rapid prototyping, using rapid prototyping facility. Implications of education. This is something of interest to us and to you. Now, if you're looking at future education, okay, we know these things are happening and this thing is coming and product has to be made. We understand all that is very good and all that. Okay, but then in terms of education, what is it that we are looking at future education for, especially engineering education? Number one is that it has to be interdisciplinary now. This is something which is very, very clear, that the way we have been teaching, the way things have been going on, it cannot remain that a person is just mechanical or a person is electrical or computer science. There is some amount of interdisciplinary concepts which are coming inside. So without interdisciplinary work, there is no innovation. So it's very difficult to have a new product today without any kind of innovation, without any kind of interdisciplinary work. Ability to adapt to innovation cycles. Number one is this rapid innovation cycles. So we have seen that the products which are coming in the market now are coming in a very short time, and they become very popular, and then so this innovation cycle has become very short now. So how do you adapt to this kind of rapid innovation cycle? Okay. Now, then number three is survival in this industry 4.0. This requires some kind of IT skills. Okay. So maybe you'll be happy when it says IT skills are required. So it requires some kind of IT skills because you need to go over the net. You need to communicate. So these are three of the things that engineering education is supposed to be building up now. Future engineers need to be able to speak code. That's what they say. That you should be able to speak code now. Okay, so when somebody is talking in code, like somebody is showing a robot program or a code, you should understand that. Okay, this is what it means. It's a robot code. but this is how it's working. Now, if innovation cycles become faster, we need to have more enterprises. That is one. But the interesting thing here is innovation comes from fresh minds. Okay? So these are supposed to be the innovators, and all of them are high school dropouts. So probably education is not teaching anything. So very often I wonder that what we are teaching, because most of these guys have never graduated from anywhere, right from Bill Gates to including Zuckerberg to Microsoft. Anyway, the Microsoft guy is not here. Okay, Bill Gates, okay, then Steve Jobs. None of them graduated. So it comes from what they say, fresh minds, okay, whatever that means. Maybe it means unused mind. I was reading in somebody's T-shirt. It was written. The students, they write different kind of T-shirts. So when I normally go to the drawing hall or something, when they are doing drawing, I read their T-shirts. And they have all kinds of writing. I was born intelligent. Education ruined me. So I don't know if it is true. So the point is, innovation is coming, yes. And most of what we are talking about is new innovation. But it is coming from people, again, who are not really educated in that sense. Okay. So the question is, how do you teach this? That's the challenge we are facing. How do you teach innovation? Okay. We know it's coming. We know products. We need to create new innovation, new products. But then how do you teach it? So the question is, how do we teach students to be like that? How is it that we teach? How do we model our courses which can teach innovation, which can teach that this is happening, this is coming, etc., etc. So classical entrepreneurship skills needed classical skills. So entrepreneurship skills needed technical skills, managerial skills. So this is basically what was being taught: entrepreneurship skills, technical skills, managerial skills. But is this enough to prepare for Industry 4.0? This is conventional education. Is this enough? Now, what we have seen is that because of this communication technology and semantic technology, essentially everything is getting connected. So outsourcing comes of age, the rise of what is called collaborative partnering. Okay? So one company doesn't make one thing, many companies make the product and then they collaborate. Then we have freelancer. Okay? These are new terms which has come up. Okay? Freelancer as a new form of permanent employment. A lot of the companies do not hire as permanent employees anymore. Even TCS, Infosys, big companies don't hire anymore. They'll give you a job, but you're not a TCS employee. Okay? You're a consultant. Okay? That means that you are being outsourced or you're a freelancer. Okay? So this is the new kind of employment which has come up. Okay? There are teachers, I'm told, okay, professors who teach in 3-4 engineering colleges. Freelancing teachers now. They take one lecture here, then they take one lecture there. In the big cities, it's very common now. It has become very common, freelancing teachers now. Okay? And so freelancing is a new form of permanent employment. Okay? So before, what you said used to be a sarkari nokri and all that. Okay? And so this is a freelancer who doesn't have any employment in the sense, but is employed and is freelancing. So right from not only coding is IT companies are extensively using coders who are freelancers, people who stay at home and work. Okay, they are specialized in a particular area. Then even teachers who are teaching in different places, okay, and are not associated with any institution. Okay. So freelancing is something which is coming up, and this is flexible, specialized, linked. Again, in particular, high wages countries are under pressure because human beings are not there. Okay. So they are also looking for this concept of freelancing. We don't have freelancing students till now, but we might. So you have freelancing teachers, so why not freelancing students? Need-based, because it may sound funny, but in the industry they want that now. The industrial people want to upgrade their skills. So we run here courses for upgrading skills for managers, where they don't want the formal courses, they just want to upgrade skills in a particular area, and they'll come whenever they want to come. Okay? So that is probably the idea of freelancing students. So they don't want a formal degree anymore, they just want to upgrade some skills. So the question is, can you offer that? Okay? Not a formal course, but just upgrading. Implication of future engineering education, new business thinking. taking risks and dealing with uncertainty. This is nice, bustling with creativity. So we have to somehow get into this concept of new business thinking, okay, from the conventional. Taking risks and dealing with uncertainty. Okay. Then creativity is and innovation is something that we need to teach. The question is how. Some people have thought about it, how to go in this direction. One way is by looking at this, what we call massive online courses. Okay. So this business of industry people, even teachers who cannot come during the regular time, unlike you who are forced to come. Okay. So they can go and use what we call this massive online courses, and online courses around the world are even giving degrees today. Okay. That you can take this course whenever you like it, you can take the exam, and you can get a degree. Okay. Some of them charge some amount of money for it. So I think IIT Kanpur and the other IITs also have a lot of online courses now. A lot of the best universities in the world, okay, MIT, Stanford, all of them have online courses now. Okay. Coursera is there, which is offering online courses. So if you want to upgrade a skill in a particular area, then you can just take the online course and then and upgrade the skill, and they also give a certificate. NPTEL also is doing the same thing now. So one way forward is by looking at online courses, okay, what we call massive online courses for dealing with. Khan Academy is probably very popular. Coursera is popular. This guy is very popular. Okay, and so this is one direction which you have to go. Okay, so we need to think about this. You need to think about this. That future education is changing, and we need to log into this online course kind of a scenario where we are teaching courses not only in the formal way, but so this is the higher education. This is the usual recipe, face-to-face teaching like here. Then you have online distribution of learning material, group peer review. You have some kind of exam, certificates, there is feedback, and there is lab experience. This is standard what we are doing now. Okay, so this is exactly what we have done here: face-to-face teaching, labs. We have lab experience. We have exams. Now, if you look at higher education the new way, the face-to-face teaching is with a virtual character now. Okay, so you have an online course, and in which there is online distribution of material, which is here. This group-based peer learning, exam certification is online, and feedback is online, and lab experience is also online. Okay, there are some companies which are offering. We have started, but it didn't go very far. Is to have a lot of these education institutions cannot buy robots. So can you have a robot in a centralized location, and somebody can log in from wherever they want and run the robot? That's a lab. Okay. NPTEL has started it. Somehow it didn't go very far. Okay. So you don't have to buy your own robot. You can use a robot in a central facility over the net, and that's a completely virtual way of doing experiments. Okay. So this is the direction in which we need to look at. You need to look at. People are moving in this direction now. This is what they say. MOOCs are nice, but there is a shift in the education in terms of accessibility, in terms of making education smart, individualized. So this is the direction in which we are going. Okay. So PCs for everybody, log in and learn. You can even do it over the net now. If you ask Google, Google is probably the company which is doing most of it. They are into everything, okay, right from cars to about big data in terms of offering MOOCs and so this is essentially to do with big data. So let's not get into big data. The other concept that is becoming very common is globalized education. You're not giving education only to your students in a limited domain, but you're giving or delivering education in a globalized way. So anybody can look at these courses, anybody can download the courses, read them in a global kind of environment. And this is essentially for society, individuals with special needs, non-privileged special needs. Okay. So this is something that we need to keep in mind today, that our education not only has to be focused towards the classical sense what we have been doing, is towards that individual. They might be non-privileged, they also could be having special needs people. Okay, how would you do that? Now, the government of India has set up a task force, okay, on AI and Industry 4.0. That in India, what should be the focus areas? What are the companies who are interested? And what is the way forward? So all different countries, China, Japan, Singapore, they have done it. So maybe looking at that, Government of India also said, yes, we should also do it. So they also set up a task force about 3-4 years ago. And this is the Indian basic scenario, is that while large new companies in India, in particular e-commerce businesses as well as small startups, are beginning to exploit AI, traditional enterprises, especially governments, on the other hand, do not seem to be aware of the potential of AI and have not been investing much in AI applications. So essentially, government and Indian large big enterprises, they don't seem to be moving fast in that direction. It is essentially the new startups and e-commerce companies, okay, which are selling, retailing, they seem to be going in. Now, what are the potentials for India? What are the challenges? Data collection. So the major challenges deploying AI systems in India is data collection, archiving, encouraging data availability with safeguards, data marketplaces, exchanges. Now we talked about medical data does not exist. Okay. Then even in companies like Tata Motors, if you say that this car has been designed, they actually do not have data. Their own data they don't have. Forget about having somebody else's data. And if they have the data, they don't want to give it. They'll say it's privacy and all this. Okay. And whenever they say privacy, most of the time they don't have the data. Okay. And so data collection, this is a major challenge today, okay, in India. Ensuring data security. Okay. How do you, when you have the data, how do you ensure data security, protection, privacy? Digitization of systems and processes. Okay. All the data that we have, whatever we have, prescriptions written by hand, they are not digitized. Okay. There is no soft of that. Similarly, deployment of autonomous products, robots, autonomous vehicles, this doesn't seem to be there. Okay. So in India, all of this seems to be a major challenge now. Okay. So if you want to move into this industry 4.0, then we need to get into all these areas. And now government policy, in terms of policy, the questions that are being asked is, what are the areas where government should play a part? Okay. How can AI improve quality of life and solve problems at a scale of Indian citizens? What are the sectors that can generate employment? So how can you generate employment? That is a major focus. And the grand challenges of India, seen from the perspective of the grand challenges, is improving manufacturing to increase profitability and increase manufacturing jobs, improve healthcare, improving agricultural yields, improving delivery of public services. Okay, so the focus areas of Government of India now is on these 4 areas: manufacturing, healthcare, agriculture, delivery of public services. Okay. And they have looked at healthcare. Okay. Now, healthcare is something where we are lagging behind in almost most of the countries because our systems are not digitized, okay, and the way it is not connected. There is no concept of insurance. Okay. So, creating electronic health repositories, creating national scale clinical decision support systems, creating self-learning systems. For example, overseas there is a computer system called Watson. I don't know whether you have heard of it. IBM has a very famous machine called Watson. Okay. And the function of that Watson is to read X-rays. So if you are having cancer, like chest cancer, okay, or having lumps in the lungs, okay, so only a very trained radiologist can actually read it and say. Now, if you don't have access to it, this is a machine which can actually do that, okay, and it is trained to do that. No, an X-ray, from X-ray. X-ray. So looking at the X-ray plate using vision, it looks at the X-ray plate and it can actually detect that whether it is normal or there is a cancerous lump somewhere there. But it's a machine which can do that. And Watson is being used in many countries today, and especially countries like where they are giving it to countries where they have less doctors, like Africa and other countries. So they can use the machine, take an X-ray, and at a first stage, as a first step, it can do the first diagnosis. So that is machine learning using AI, creating national scale clinical decision support systems, creating self-learning systems. So for very small sensors for testing blood, for example, okay, there can be automated blood testing now for malaria, for dengue. Okay. So can you develop systems which can do that? This is an example of healthcare. So the government also feels that these are areas where we can get in agriculture. Okay, in India, we are still an agricultural country, and agriculture is something that, so crop prediction. Okay. In fact, all the IT companies have got into this now. If you see what they are doing, they are trying to get into all these areas now. They look at this report and then see where the job is there. So they also want people who can do this. Okay. Crop prediction, crop health, very simple. Take pictures, and from that, can you say that, say for example, there are pests or some crop is sunk cost of post-harvest losses. So in terms of this, each one of them is business today, and all the IT fellows are getting in here. Then we have manufacturing, digital business transformation, AI-based logistics, improving quality through AI-based predictive maintenance, creating hybrid teams, judicious introduction of autonomous vehicles, etc., etc. Manufacturing is another big area where all of this is applicable. Education, okay. AI-based analytics to accurately measure outcome and thus help government in resources, create dynamic courseware. This is something where we have been looking at and we have been trying. So this is something that you can also look at, because at some point of view, at some point of time, you will have to be in here. Teacher training in developing of tech-enabled solutions. Okay, this was one such teacher training. You are expected to go back in your institute and also do some training. Okay, so that is expected of you. Okay. And whatever has been learned here, at least in terms of sensors, actuators, controllers, basic robotics, basic automation, this I'm sure you can do. There is nothing big in it. Now, in terms of this teacher training, you are expected to train about 50, I think, 30 or 50 this year itself. Okay, so which will also require lab facilities. Okay, so for lab facilities, you can write small proposals to MHRD, just equip NPIU. So they're giving money also. Okay, so you're supposed to train them in the areas of sensors, actuators, controllers, basic robotics, automation, and the cost required. Cost is not much. Okay, with 5 lakhs or 10 lakhs, you can make a very good lab to train 50 people. Okay. That money is also being given. So what I would suggest is, after you go back, please look into this, write a proposal through your institute to NPIU that you have to do this training, and that has to be hands-on, okay, for which you need money, which they are giving. Okay. So please do this. So this is something which is very important for teaching our students also. The next generation of students must know, okay, the current state of sensors, actuators, controllers, making technologies accessible to all, schools deploying them in collaborative teacher-student mode. The other thing is, there is a lot of interest in the schools. Okay. Robotics and automation is something which is, even students are interested. Why? Because if you see a robot moving, if you program a controller and something is moving, even not from a school kid, even from my perspective or your perspective, the moment you see something moving, or I have written a program and it is moving, you get excited about it. And you can change the program, see something else, which you can't do in something like physics or chemistry. So there is a lot of focus also on trying to help schools in trying to make this popular. Okay. Not only in terms of robotics and automation, but in terms of, in general, technologies. Environment. Okay. So in India, we had agriculture, healthcare, education, environment. So intelligent automation to estimate, control at source, pollution, level of smoke, intelligent automation to estimate, predict depletion of natural resources, prediction of meteorological events, cyclones, floods. These things are already being done at a larger scale. Data security. Okay. So there is a lot of data breach and this, that, but somebody pointed out, in India you don't have data, so how can you have, why do you need data security? So data security is something, if you have a lot of data, then how do you secure it? Okay. So there is a lot of talk of cyber security, data security. Then national security, this is something which is there. Okay. Autonomous surveillance, combat systems, adaptive communication systems, AI-based cyber attack mitigation, multi-sensor fusion-based decision-making systems. So in terms of national security, these are areas which are completely open. Now in terms of ethics, okay. Now in the Indian focus, this is in terms of the Indian focus. Now in terms of ethics, there is something also that we are into ethics now, that we have to work about in terms of ethics. Okay. So ethics in terms of all this is still not defined. Okay. We said that the laws for robotics is still not there. Okay. So ethics is another big area which has come up new now. Okay. So this is also an area where to teach ethical practices so that it does not infringe upon ethics. For example, there are a lot of machines which are killer machines today. Okay. They can kill. So United Nations has a rule that you cannot, the ultimate decision for a killer machine has to be with a human. So for example, when a drone is flying and dropping a bomb somewhere, the ultimate decision is always with a human. Okay. So that is United Nations regulation on machines as of today. Okay. So United Nations also has a group on killer machines. I didn't know that. And India has a representative there in Geneva. And their job is essentially to make look into ethics. And the ethics today is that in any system of any defense application, the ultimate decision is a human. It cannot be a machine. Okay? So till now it is there. But the moment it goes on to a machine, then we have the scenario of Isaac Asimov. Okay? The machine is taking over. Okay? So the ethics of whatever we are talking till now is that there is a human in the loop, and the human is at the top of the command. The ultimate decision is human decision. Okay? That is United Nations guidelines, and it should remain like that. That is something which we should keep in mind also, that there is a man-machine system, all this is intelligent, AI, very good, but then it's a human who is on top always. Okay? Okay, so I think we'll stop with this.